It is super hot. It's all right, let's get going. Take out those guided notes. Let's keep rocking and rolling through. We made it actually really far yesterday, which was awesome. We got to like work through this one, which ended up kind of being a little nasty in terms of like having, I don't know, like a lot of things to look out for. Factoring at the -3 and then having to factor the quadratic that was left. And then, oh, I got to factor the bottom. And I had to know that I had like 2 factors of each. And then so I could square. Oh, man. So, I mean, it was kind of nice. And even sometimes I'm happy when things work out nicely that way with all the simplifying that we can do after we take the derivative. But we've seen with the product rule, you know, sure, it works, but sometimes it's more work than we were hoping for. And we saw that if we could like mess with the function first with the product rule, if we could just rewrite it, the derivative got a whole lot easier. And as nice as this one worked out, right, to be able to factor and simplify, that's usually a clue that we did not save ourselves from the work by jumping right to the quotient. And it doesn't always work out this way, but if the derivative was factorable and simplifiable, pretty good chance that the function was first. And maybe doing a little bit of work ahead of time, kind of looking down at this section right here, maybe doing a little bit of work ahead of time, not on the derivative, but on the function itself. I'm going to go like this so I got a little more space to work. Like that. Giving ourselves a chance to just rewrite the function instead, I think is going to pay dividends for us. So take a look at that function. X squared plus 3x plus 2 over x squared minus 1. What could we do, top and bottom, to make, hopefully, our lives a little easier? Factor, with the hopes that we can divide some stuff away, right? So we've got quadratic up top, so hopefully that's factorable. Quadratic on the bottom, that one we know for sure is factorable because we factored it as part of our work for the last time, right? X plus 1, x minus 1, in whatever order, right? You can kind of pick whatever you want. What is the top factor? X squared plus 3x plus 2. Two numbers that add to 3 and multiply to 2. 2 and 1, nice. And because it's just x squared, it's just x plus 2 and x plus 2. So what do you see? Love it. See ya. Rewrite the function first. Now, the thing that we want to keep track of is the fact that, although, yeah, we divided away that x plus 1, top and bottom, that is still a value that's not in the domain, right? Because there's a hole at -1. Now, what's written in red there is pretty obvious. I think that 1 is not going to work, right? So that value is still obviously excluded. But I think it's important that we say that -1 still doesn't work. I know we just divided it away, but the reality is the function is what's in blue, not what's in red. And we want to keep track of those excluded values because, and it doesn't happen super often, but they might like say, okay, like what's the derivative at x equals -1? And if we don't keep track of this, we might say, oh, f prime of -1 and like go for it, when really we can't, right? Because there's still a hole at -1 comma something, whatever it is, and an asymptotic one. See that? Remember that? So keep track of those excluded values. Yeah. Because this factor right here, although we divided it away, is still part of the original function. We're just simplifying it so that our derivative work is easier. But keeping track, and I'll label it right here, right? Keeping track of those excluded values. There's only one of them, so I'm just going to say excluded value. But if you have like multiple factors you divide it away, you want to make sure that your function and then your derivative after the fact kind of keeps track of it. Now, usually they won't do that, right? They won't say, hey, let's do f prime of -1 and kind of trick us. But they might, right? They're tricky, those ancient calculus. So we just got to watch ourselves. But wow, this is going to be so much easier now to say, oh, u is not that quadratic from the original. It's just this linear term up there. And so du, beautiful. Oh, so nice. V, the denominator, x minus 1, oh, dv, sweet, 1. And those individual pieces that we're going to use in the quotient rule are now so much easier than the quadratics that we had to deal with in the top half of this page ever was. And now we can just jump in, go for it. How many of you think you can close your eyes and know what the quotient rule is? That's pretty good, nice. That's what you want to build to, okay? I don't know when we'll do it, but like I said yesterday, I'm thinking like first half of chapter 3, we'll stop and assess, and then we'll see what we got. All right, let's go for it up front. VDO plus, nope. VDU minus. V. DU, I'll put the 1 just for good measure so I can show off that I know what I'm doing. U, dV, right? VDU minus UDV all over V squared. Again, we'll multiply out the tops. We're going to leave the denominator factored in hopes that one of two things happens. Number one, maybe we have an x minus 1 we can divide away and we'll simplify. Or two, we don't, and we didn't do any work in that. Right? Save yourselves as much trouble as you can. I'll go this way. Multiply out the top. Let's see what we got. Oh, well, that's easy. X minus 1. And then minus, and I'm just going to play it safe. I'll keep the x plus 2 in parentheses for now. I could have put like minus x minus 2 if you want to kind of combine some steps there. That's cool. And I'll leave the denominator factor, though. I'll leave that as x minus 1. Again, this x minus 1 and this one cannot divide away yet because you don't have an x minus 1 ever. But this simplifies real nice. X minus x, gone. Negative 1 minus 2. There's that negative 3. You can put the negative up top. I'm just going to leave it out front. That's just a little nicer, a little cleaner. And then x minus 1 squared. And that was a derivative that we found the first time they told us we were supposed to find. But wow, that was so much easier, right? Way easier. So a couple big takeaways from this, and that's kind of what they asked there at the bottom. If you've got a product and you can expand it first, do it. If you've got a quotient, try to factor and simplify. Right? We want to try to like mess with the function first. It seems to lend itself really nice. Rarely are you doing work that doesn't help. Usually it's definitely worthwhile to give it a shot. I mean, this took like 3 steps. It's awesome. It simplifies nice. I don't have to worry about factoring later. We factor and simplify first. We usually don't have any factoring and simplifying to do with the derivative. And you saw that if we don't factor and simplify first, we had a lot of factoring and simplifying to do that. But there's a portion. VD minus. Cool? All right. Now, I don't know, like what haven't we done yet? Like think about like in terms of like what kinds of functions we've dealt with, the kinds of derivatives that we found. What haven't we looked at yet? Think about it. Is there anything we haven't done? Bling? So like having a fraction that has like sine and cosine in it. We didn't do that yet? I think you're right. I don't think we've done anything like that yet. Okay. So having some trig stuff in a fraction. Well, let me ask you this. What is sine over cosine? Right? Because that's kind of what you're saying. Let's make a fraction that has sines and cosines in it. What is sine over cosine? Tangent, right? Turn the page. Top left. There it is. Nice. Did you sneak a peek? Did you know that was coming? That's what we can build to now, right? Now we've got fractions that have some algebraic stuff in there. Let's get some fractions that have sine and cosine. Because every trig function is just a fraction with sine and cosine, right? That isn't sine or cosine from the beginning. But I think that's the way we should probably go about it, is if we're thinking about like what we know how to do, like we know how to deal with fractions. We know how to, like, we know what the derivative of sine is. We know what the derivative of cosine is. Let's take something like tangent. Let's rewrite it in terms of sine and cosine and make it a little bit simpler for us. Let's rewrite f of theta as sine of theta over cosine. Let's see where that gets us. So u on top is sine. V on bottom is cosine. And we know those derivatives separately. And now we can just kind of put them to work within the quotient rule to figure out what the derivative of tangent is going to be. That's really our best shot. I mean, we could we try limits. Ugh, no thanks. I'll just let the quotient rule hopefully do all the work for us. Now, the hope here at the end, though, whatever happens, because we can rewrite tangent as sine over cosine, like there's always a way to rewrite it as a fraction. At the end, let's try to get rid of fractions. Let's try to rewrite it so that it doesn't have any fractions as part of the answer, because every trig function can be rewritten as its reciprocal, and we can just go from there. So, I mean, fingers crossed, it's just in terms of like just sine or just cosine or something like that. But if we have a combination, then we're just kind of stuck with what we've got. Let's see how it plays out. F prime of theta right away. V, okay, cosine, times, and parentheses if you want. I'm going to make my life a little simpler. Times du, oh, another cosine, okay, minus, so this is a big fraction here, u sine of theta, times dv, oh, okay, another negative sine of theta there. And what goes on the bottom? V du minus u dv all over b squared. Okay, so cosine squared. Well, I could write it like cosine with like parentheses around it and then put the squared on the outside. Or we can just write it as cosine squared and I put that square in the spot where it's supposed to be, right? But remember, that's just cosine times cosine. Again, we can't really like divide these cosines because they're not factored yet. So let's kind of multiply out the top, right? That seems to be a pretty popular thing for us to do next. Multiply out the top, let's see what happens. So cosine times cosine, okay, there's a cosine squared. Again, I can't divide that yet, it's not in common. Minus, and just so you see it, minus negative sine squared. Plus, I like it. Cosine squared plus sine squared on top. And for now, cosine squared on. Okay. Now with algebraic stuff, okay, here's where I would like maybe factor and hope to simplify. That trig stuff. There's nothing in common up top, so we're not factoring anything. But do you notice anything that we could do to make it simpler? Yeah, what is cosine squared plus sine squared? 1. Nice. We went from 2 different trig functions now to just one. We went from a binomial up top to a monomial. Now we just have this one rational function. But it, like I said, it's rational. So I don't want to leave it like that. If there was a way for me to rewrite 1 over cosine squared so that it wasn't a fraction. There it is. The derivative of tangent is secant squared. Which is great. That it works out that way. But so anywhere, stop anywhere on that crazy tangent function, right? You get these asymptotes at like pi over 2, 3 pi over 2, 5 pi over 2. Stop anywhere you want, draw a tangent line. It's the value of secant at that spot. Bananas. Oh, so
Why can't you just cancel out the 2%?
this one right here.
Yeah.
It's like, so don't write this, but it's like trying to do this. Let's say 4 plus 1 over 4. It's like doing this, right? Now, 4 plus 1 over 4 is 5/4. You just changed it to 2 because you didn't factor things out. If you want to divide things away, like you think about order of operations. I mean, this is my Algebra 2 version. Not PEMDAS anymore. I call it GERMDAS. Grouping, exponents and radicals, multiplication, division. You have to be here. If you want to divide, you have to have things that are multiplied together. You cannot attach division to addition and subtraction correctly. As much as we would love to, right? I wish I could do that. It just doesn't work out, man. There it is, secant squared. Nice, cool. Now, I'm not going to do cotangent yet. We're actually going to slide straight down and go after secant first, just to kind of see how that one plays out. What's that? You think this derivative of secant might be like the other one? Maybe. Let's see how it works out. Let's see. We're going to go after this one the same way, and hopefully things are nice. I have no idea what secant is, but if I could get it in terms of sine or cosine or even tangent now, right? Because we know the derivative of tangent. Let's rewrite this in terms of something that we know the derivative of. Now we know sine, cosine, and tangent. Maybe a combination of both or just one of them. What is secant? 1 over cosine. There's my function. That's a 1. 1 over cosine. So u is just 1. So what's du? 0. The derivative of any constant is 0. That means that when I do like my du part times whatever, it's just going to disappear because we're multiplying by 0. Nice. So v is the denominator. There's cosine. So dv, negative sign. And we're ready to go. Okay. When we write this, we'll see how this plays out. Maybe it'll look similar to the one above. We might need a different strategy. Let's see. V, okay, cosine theta, times du. Oh, love it. 0, minus v du minus u, 1, times dv times negative sine. If that just bugs you, put parentheses wherever you want. All over the denominator squared, right? V squared. So there's another cosine squared there. All right. Let's see what we get. All right, so cosine theta times 0. Goodbye. So what's the only thing left up top then? Minus negative sine. Minus negative sine. So sine. Yeah, okay. Sine of theta over cosine. Now, the last one was really nice because it was just 1 over cosine squared, which was just secant. Now we've got kind of a combination, sines and cosines. So I think it's kind of time to play with some ideas and see what works out. I think there's a few different routes we can go, but you want to kind of think back to like a pre-calc chapter 5 mentality. It's time to start like rewriting things, and breaking them apart, and trying to find ways to write it without fractions. That's my goal. So what do you think? What could we start with? Yeah.
So if you break it up into sine over cosine times 1 over cosine.
Right? Get yourself, if you have 2 things being multiplied on the bottom, 2 different cosines, well, I kind of want 2 things being multiplied on top. A really common strategy for us in chapter 5 with identities, if I have things being added or subtracted, I could break them into 2 functions being 2 fractions being added or subtracted. I don't have any addition or subtraction here, so I have to break it apart using multiplication. I'm going to put the 1 first because that's my leading coefficient. So I'm going to do like 1 over cosine and then sine over cosine. Because at least now I don't have to deal with squares. And maybe your thought was, hey, oh, I see something squared. Let's try like 1 minus sine squared on the bottom, like rewrite it all in terms of sine. Well, now you've got a binomial denominator and you can't split it apart. I mean, you could try to factor and then split. Ooh, don't make your life harder. Let's try to make it simpler. Okay. Well, what is 1 over cosine? You can. And what is sine over cosine? The derivative of secant is secant tangent. So you're right, there was a tangent in there. Nice. But that's crazy. So it's a secant function. We didn't even look at what secant looks like. It's kind of funky looking. I forget. Let's see. Cosine is well. It goes like this. It's an asymptote, then like that. Did we look? I forget. Maybe we graphed them once, right? It's so funky, but it's so cool because now stop anywhere you want on this graph. The derivative of that is the secant of that value times the tangent. But cool. Pretty different though, right? Tangent was secant squared. Okay, so the degree of that was 2. What's the degree of this? secant to the first times tangent to the first, also 2. Okay, nice. So at least there's some consistency there. But isn't that kind of weird? The degree went up instead of down. Kind of fun, right? So the whole like changing of degrees, right, with the power rule being always we're going to drop it down 1, that's algebraic. Anytime we get outside of algebraic functions, so anything trig, anything exponential, and of course then anything logarithmic, which is coming, it's not going to kind of follow the same path there because we have a lot of different ones. Okay? Looking good. Such a good look for you. All right. Now you try. Try cotangent. Here's your hint. Follow the same path as you did with tangent. And then try cosecant. And see what happens there. Thinking the same way that we did about C. See what you got. I'll give you a minute, then I'll start working through cotangent. So this was secant squared. What do you think it's going to be? Maybe. Maybe. Let's find out.
I don't know.
Let's find out. Maybe though. Rewrite it for sure. Cosine.
They'd be like,
and then we'd be down in the time.
Oh, that made me so proud. That was amazing. That's negative. Negative.
I know, me too. I just saw that.
Very good. That's all I can hear.
What up, Twitter?
I am. Okay, I have places to stop me.
Oh wait, no, that's not negative. Can I just?
Factor out a negative, or
Sure.
so that you can get the way that you just said that.
Sure, because you got what? Negative sine squared minus cosine squared.
Squared over sine squared. So do you factor out a negative so that you can get it to plus?
Okay.
And then it would be sine and cosine. So it just be 1 over sine squared. Oh, I'm brilliant. Don't even worry about it.
What is it?
I know it's cosecant.
Negative.
I was like,
Sine squared plus cosine squared is 1. Negative sine squared minus cosine squared.
be allowed to have our shortcut thing on.
I'm gonna tell you what I need you to do on this.
Okay.
Once we do cosecant, I'm gonna show you something, and I will show you what the first question will be on this.
I'm the hater. I'm just like stressed because I can't remember a lot of the shortcuts.
Oh, like the product rule and the quotient rule, like kind of like written out somewhere?
Like
Okay.
the trick shortcut.
Oh, yeah, of course. Yes.
Okay.
Called the cheat sheet for a
That's what I was
reason.
worried about.
Yeah, no, I thought you meant like the product rule and the quotient
Oh,
rule.
no, that's
All the identities, yeah, you do not have to know. How'd you do? Yes, sir.
That was the funniest thing I've ever seen.
So this right here is negative. That didn't sound good. Sine squared. That is one.
My reaction time is just so
One of the
delayed.
trick ideas from last
On the other side, I
I
can
use
distract
all
them,
the time.
and I'm like, what am I doing again? I'm like, it's okay, act like it. Don't love it. 14 minutes.
Otherwise,
Dude, I have to fucking tonight, I'm like, words.
This is a good one. It's not as detailed as some of theirs, but there should be. There's the other one.
What was the reason for
What was the
This,
reason?
the other page is
fire alarm?
The kitchen let off and I had defective alarm.
so you kind of interchange the two.
It's just to have a thing.
And each
Say
thing
that
has
it's
to-
It was fresh baked cookies and they put them in the freezer to cool off, and then the water vapor and condensation causes the fire alarm to go off.
More like plug-in numbers.
Everyone just stood there, like this.
Identities.
Like, everyone just
You know,
stood
we
there,
base
was like,
data and
go outside.
negative cosecant squared for the first
At least I
one.
know what's going on in AP Psych.
Negative cosecant squared. So this one was secant tangents. Video killed the radio stuff.
I'm so sorry. I was just
So what do you think this one's going to be? So it went tangent was secant squared.
1 over
Cotangent was negative cosecant squared. So it went from positive to negative and from secant to cosecant. This is secant goes to secant tangent.
Oh.
So what do you think cosecant?
Cotangent.
So you think it's going to be negative cosecant cotangents?
I don't know, negative secant tangent.
So just switch the sign?
No, secant, it's secant negative cotangent.
So the derivative of tangent was secant squared.
Yeah.
The derivative of cotangent was negative cosecant.
Negative secant, negative
I got a hand map.
Okay, let's see.
I'm sorry. I just,
So let's rewrite it 1 over sine.
I can't get over, my brain is giving me trouble.
So u is 1, so du is 0. So b is sine, so dv is cosine.
Cool, that's what I got.
So then the
Good start.
video.
Also
Video.
video minus video minus.
I had one memory of Blockbusters.
Yeah,
I went to go buy the Teen Titans
nice.
cartoon movie.
Uh-huh.
The Bratz movie. That's it.
There you go.
Oh, I went to Blockbuster like every.
Shut up.
I can't talk today. Leave me alone. I'm gonna fail my AP Lit exam, and I'm very not happy about it. Anyway, yeah, the talking thing.
Oh, yeah, your panel.
Anyways, let me figure out real quick.
1 plus 1 equals 2. And 6 plus 2 equals 4. Oh, break it up.
Same style. Same style.
Alright. I
Negative
like
1.
your style.
Who's gonna tell them? I agree. Oh.
So what do we get?
Negative cosecant.
Negative cosecant
Oh, it's cotangent.
cotangent.
What I say about cotangent?
There it is. Very nice.
I knew cotangent, but I didn't know.
Hi, Grace. You missed some fun times.
I'm excited. Oh my gosh.
No.
I got. We'll formalize a little bit.
I kind of block out my.
Negative cosecant cotangent.
Period.
So tangent was secant squared, cotangent was negative cosecant squared. Sine switch becomes the cofunction. Secant is secant tangent. Cosecant is negative cosecant cotangent. Switch to sine, use the cofunction. Every single time. Now, I don't know if you have noticed, but that is true for all six.
Whoa. Hold up.
Wait, hold on.
You're going to get it from me eventually. I have a document made up with all the derivative rules, but it includes things we haven't done yet, which is why you're not getting it yet.
Oh, okay.
If it does not have a co in the name, the derivative is positive. If it does, the original function does have a co in the name, so the co-function, it's negative. Sine is cosine. Cosine is negative sine. Switch the sign, use the co-function.
Wow.
Tangent is secant squared. Switch the sign, use the co-function. Sort of. Yeah, sort of. Because secant and cosecant aren't reciprocals of each other. So, but secant, look, no co-functions here. Ooh, co-function, negative co-function. So you really only have to know 3 of them, and then you'll know the other 6. Okay. Question number 1 on our quiz. I'll erase my erasing here in a second. Okay, there's question number 1 on your quiz. Here's your trig function table. Okay.
I think it's a no for me.
Huh?
Right?
Not yet. We don't know enough yet. Because this is rule number 7. You do not know rule number 6 yet. That's the next one after the quotient rule. We'll do that tomorrow. And then there's 8, 9, 10, and 11 after that.
So this quiz is far out.
So if you would like to take a picture of this and then put it somewhere nice for you to look at, I just think it's organized in a way that's easy to. Okay. Maybe what I'll do is I'll make a copy of this and I'll take out the stuff we haven't done. Because, I'll give you a second. I think that this makes it so easy to just to read. Okay, because so number 6 we don't know, so chain rule will show you that, but quotient rule, product rule, constants in general, power rule, limit definition, possible notations. But after that, exponentials, logs, inverses, and something called implicit differentiation. When we do not have functions, all that fun stuff is gone.
Is seniors be gone by then?
You might. Implicit is chapter 4. Implicit is chapter 4, but that's where it gets fun. We can blow up a balloon. We can like cut a hole in the bottom of a cone and like watch stuff like drip out. Like so much fun stuff we can do. So much. We can like watch how shadows change. There's a lot of cool things we can do with implicit. Absolutely.
And like not get a grade.
Absolutely. You can audit the last half of this class. Sure. All right. There they are, all in one nice place. We've got 15 minutes. I want to give you a chance to try it out. Bottom of 191 and top of 192. There's 4 questions there. Maybe you can get all 4 done today. Maybe not. Do the best you can. I'm going to work through them right away. And then tomorrow will just be a big quotient rule practice day to start. We'll have at least 20, 25 minutes to work through, I think it's page 194, 195, which we'll call homework 3.2. I don't think we'll need the whole class to do it, although it is a shorter Wednesday, so we'll see how it plays out. I want to start wrapping up this first half of chapter 3 with the last of the 3. We know product rule, quotient rule. We need another one. And it's different. It's different. It's where like functions start to get like mixed in with other functions. Composite functions like f of g of x. Like not just x squared, but like what about sine squared? Is that just negative cosine squared? We gotta see how that plays out. So we got some composite functions to deal with. I just can't take you seriously. So go ahead, see if you can work through the bottom two here. I think those are pretty straightforward. As much as I would love like f of x to simplify, factoring out the x doesn't do me any good. But I think it's more like if I were you and I'm oh my goodness. If I were you and I'm doing this for the first time, I definitely like start here. It takes me all of 5 seconds to factor that out. And then I get sad for the next 5 seconds. Then I accept it and I move on. And I just go, yeah. If I factor out a negative x, now it becomes negative x plus 2, and those are not the same. So when I factor out a positive x, I don't have common factors down bottom. If I factor out a negative x, now I have negative x plus 2, and that's not the same either. So I know, it's so close. Like, just make it x squared plus 2x. Come on, you feel me? But it doesn't work. So we just go for it. Luckily, it's just quadratic on top, linear on the bottom. So it's not terrible. It's just good quotient rule practice. And hey, at least dv is 1. So I'll do these two. I'll leave it up for a second. Then I'll work through the top two on 192. You'll see with that last one, our fourth practice one today, the top right on 192. You're going to want to rewrite that numerator first. And you'll see what I mean once you turn the page. Video on. I'm expanding to do there for sure. Minus. Again, expand, simplify, then maybe we can factor. Maybe not. Usually, if you cannot factor and simplify, and it's just algebraic, like this rational one right here, you probably can't factor and simplify later. But once you start mixing and matching, like with p of theta right there, maybe there's something. All right. Telling you, once you get to Calc B, you are going to yearn for the days when Calc A was the easiest thing.
I hope we all know that.
You're gonna feel like this is easy, and that's good. That's I think that's what's called learning. Things are hard, and then they get easier. It's so weird. You learn something, you practice it, you get better, it gets easier, and then we move up.
I think that's what's called learning.
I think that's learning.
I think it's called perseverance. Like, I could be wrong.
Maybe.
Wait, I think I did this wrong.
Okay.
Oh, I keep shedding.
I just feel like
The second one? Or the
the first
I feel like a 40-year-old
didn't look up.
It's fine.
If you're getting rid of the x squared, there's two. Oh, there's an x. Okay, sorry. I'm sorry. Yep. That makes sense. Keep doing what you're doing, queen. Keep going.
Keep going.
Keep going, queen. Live your life.
I don't think it helps.
Jacob Ashley.
Well, I mean,
Yes, queen.
I like it.
No, he's nice and everything. I'm just like,
What did you say? Life is hard. Life is like a mountain top.
I've seen a math teacher shirt that says, life is hard. No. Math is hard, so is life. Get over it.
I have a shirt that says,
Tough love, I guess.
what was it called? My last shirt? I don't know what it was called. Everyone laughed at it. It's not math. It's like,
I haven't seen you.
solve your own problems or whatever. It was like,
Yeah, it's like
solve your own problems.
Oh yeah, solve your own problems.
Oh,
Have you seen the one
do
where
the
like,
math, solve your own problems? That's what it was.
have you seen the meme where the lady, he's like, has a shopping cart of like 47 watermelon, and it's like, it's
I found her.
You're the reason.
I found the lady from the math problem. Yeah.
It's so funny.
It's like a guy's trunk, and he's got like 60 oranges in
Yeah.
there or something. Yeah.
There's nothing wrong with that.
I was oranges too.
I'm like,
How do you solve world hunger? That's the question. I'm trying to figure out.
I'll leave this up for about 2 minutes. And I'll do the next one.
What if I learned when you write a theta as a
That's so funny.
You're so quirky.
Your mom. Got him.
Now, so like f of x is degree 1 because it's 2 over 1, right? F prime of x is degree 0, 2 over 2. So that actually worked out nice that the degree of the rational function did go down by 1. But when you look at p of theta, the degree of that is negative 1, right? 1 over 2. The degree of the derivative also negative 1 because now it's 2 over 3. So, doesn't quite work the way that we hope, but if it's algebraic, it will. 1 more minute. Take a look. Once you're ready. And I don't know you have to show the factoring of theta, but especially from the bottom, you can just leave that as theta to the 4th. But any monomial denominators, like just square them, right? Square it. But the x plus 2 squared is
Okay, so you keep like in the second to last before you get the answer. You keep the theta because like cosine of theta, like you wouldn't pull it out because it's part of that.
No, it's like cosine of theta is the function. It's not cosine times theta, so I certainly can't factor it out. No, it's trapped in there. Cosine of theta, sine of theta, those thetas are trapped inside. There's no pulling those out. At least not that way, that's for sure. Yeah, I can only pull out things that being multiplied. Factoring is undistributing, right? Unmultiplying, so just dividing. You can't divide away a theta that's inside a tree. So otherwise it'd be cosine of nothing. It's got to be cosine of an angle for sure. Anybody else need to see this, or can I want to turn the page. I want to show you certainly the last one. That one's fun. Big, huge math quotation marks around the word fun. Okay, let's do it. Sine of theta is what that says.
I'll figure it out.
That's it. Minus cosine theta.
Yes, well.
You know, math and meth sound pretty similar.
I'm just saying, it makes sense why
People are addicted to math. Yes, it does.
Well, I was just saying it makes sense why some people prefer math over math. Like, I'm just saying.
Cosine theta minus cosine squared minus.
Again, if people have a conversation, they can do this.
Ooh, this is gonna be a fun one. Ooh, I like it
I
already.
don't understand why newspaper has a
I like
quarter
this.
silver.
This is not gonna be a fun one. No. Oh, wait, one of them factors out. Oh. Wait, is this a cowboy? No. I missed so much. Yes. No. Wait, where did the okay, what? I was like,
Sorry. I got so excited about the top. I forgot about the
that's
the one.
I had a, I was like, wait a minute. Where did the post sign? Okay.
Not done yet.
Where did the close sign? Where did one go? This is the one? Yeah. Oh.
Distribute, right? Distribute out.
Be like that sometimes.
Backdrop the negative. That's just one. Now here's where we get tricky.
Oh, that makes sense. Okay.
Was your dad in that?
No, he was a wood shop and computer science.
Oh, wow.
So the answer to the question, yes. What? Wood shop and computer science is math. So,
Wow, I get.
and my mom was in finance. So yeah, I come by it pretty honestly.
Pretty well.
I come by it pretty honestly.
Was your dad
I think
ever
so.
cry over math?
My dad ever make me cry over math?
Yeah, have you ever done like math homework with them and they make you cry? And he's like, and you're like, and then the parent's like, no, it's hard.
Rewrite f of x first. I'm gonna get to it because we only have 2 minutes left.
It's so
3 minus x to the negative 1. 3 minus x to the negative 1.
What a bitch in math.
Incredible.
I hear
Yeah,
that all
that
the
was
time.
like so funny. That was most of them.
That's what my dad says all the time.
Like, what is stagnant?
Call it stagnant.
Yeah.
You.
And I was like, Dad just shows your age, Dad. Wait, is that negative 2?
Man, sometimes it's
Oh,
X
yeah.
to the negative 2, yeah.
You're like, I know.
This is gonna be, yeah. They're smart as hell already.
Or they're you're patient though. You have to be patient. I was like, I like you yell at them. You're like, you know. I like do the dad thing. But I think it made me independent. Like, I like to get over my work dad. Type of thing.
Like, I'm
Two
rolling
of
really
them, I
fast.
should put those together.
Not bad, not like
Yeah.
that.
Put these together.
My dad is a 5th grade, and he does like all the word problems, like draw your little block. I'm
Right,
like,
yeah.
what? I said, there's no blocks in math.
I wish I wrote smaller.
Do you not have a pen?
I do. I feel better using my fingers than the pen. It's like it's kind of touchy and weird, yeah. Like a react light in my finger. Oh. Nope.
Throw back to when Mr. I don't even understand why half the time he did. I was like, we're literally.
We literally carried the class out. That's
We carried that class.
our humor. That's so great. I think it's different too, because like if Rosie gives you a look, you know you did something wrong. You don't want to disappoint Rosie.
There it is, right? Under the wire. Nasty, nasty.
I don't know how to do that one.
Yep.
I'll do that
Lots of
later.
fun. Have a good day, everybody. I will see you mañana. Remember, tomorrow's your homeroom day, so we start a little later. Or earlier? A little earlier. Oh, yeah.
You'll explain that one tomorrow,
We
right?
can start with that one, sure. We can start with that one.
I wrote it all down, but I just wrote it. Like I didn't.
You're welcome.
I didn't like process it.
It's a little rough. It's just that negative exponent because we have the 1 over x. Because I don't want to like do the quotient rule right away because then du has a quotient in it and I have to do the quotient rule just to find du. So I change it to a polynomial so I can just use the power. But then I just have to deal with negative exponents the whole way through. Fun
It wasn't
stuff.
a win-win, it sounds like.
Fun
It's gonna be like that.
Yeah. Thank goodness we don't have to do limits.
Oh my God, I'm done.
Right after this class. And it has to do with your 6-period teaching. So then the default after that is your 4th period. So that's it. So you leave me. So you just, it's mostly my 6-period class that I do. And only like half.
Oh, but
But Jacob, to this back.
How did it go?
Good. It was really easy.
Oh, nice.
It was first time.
I was only going into that.
So yeah, we're just gonna stick around right after class. But there probably is somebody here because my 6th period hasn't been C. But they're pretty plenty of little spots. Yes. Like 4 there. And homeroom kind of changes from day to day, from week to week. Tomorrow we're just doing great just to see where it's at. I'm getting pretty close to the end of the year. Just to see if there's anything I can do to kind of help out. But for you, it can just be a time to see how tomorrow goes. This is quickly getting harder, right? Things are progressing pretty quickly, and that's going to keep happening. Like we start off really slow in calculus, like doing things that kind of like logically make a lot of sense. And you get to these rules, and it's just about practice. Practice. And lots of algebra, really. Calculus is itself. So we'll have lots of time to practice.
I think I'm gonna go offline.
Awesome.
Yeah.
All right, I'll see you tomorrow.
Yeah, bye.